Welcome to part one of lesson four, Adam Smith's Invisible Hand and the Natural Price. Imagine this, you're a curious student in present day Glasgow, rummaging through dusty university archives when your fingers brush against a weathered leather notebook. Its pages are yellowed, the ink faded, and inside is Adam Smith's own handwriting. The father of modern economics, author of The Wealth of the Nations, had jotted these notes while walking from his home to teach his political economy class. No graphs, no calculators, just real world observations from the bustling, muddy market stalls. As Smith wandered among shouting farmers and haggling buyers, he recorded three vivid scenes from the corn market. Picture the scent of fresh bread mixing in the air with the smell of livestock dung, the clatter of coins, and the tension of scarcity and plenty. Each stall belongs to a familiar local figure, perhaps gruff Farmer Brown with his overflowing cart, or shrewd Farmer Gray guarding his meager sacks. Prices swing from 12 pounds sterling to 20 per sack, shifting with weather, war, or meddling magistrates. Smith saw how self-interested farmers seeking profit and buyers hunting bargains naturally pushed prices toward the natural price, where supply meets demand. Now it's your turn to step into Smith's shoes. Analyze the tables below with Excel, a tool he could have never imagined. Will prices crash after a bumper harvest or soar under a trade ban? Connect the dots to the wealth of nations and see how the invisible hand guides the market. In Smith's day, though supply and demand curves had not yet been formalized, the relationship between how much corn farmers would sell and how much buyers would purchase at each price was alive and well. To Smith, each stall was its own micro market. Farmers set prices based on cost, quality, and expectations for the day. If a farmer priced below the natural price, corn sold out quickly. If above, sacks went unsold. This differs from today's competitive model, where farmers are price takers. Their supply corresponds to the upward sloping portion of their marginal cost curve, above average total cost, and they face a perfectly elastic demand for a homogeneous good at the equilibrium price. Each HTML table below shows 9 stalls, one per farmer, each setting a different price. All stalls share the same supply and demand. If every farmer set the same price, each would sell the same quantity. Each firm supplies lowercase q, little q, while the overall quantity in the market is capital Q. If Smith had access to modern methods in the 1750s, he could have estimated the overall market demand and supply equations, which we assume are below. My version of the equations are right here. Yours will vary from this. With capital Q equal to 9 little q, we're going to replace the big Q with what it equals, 9Q. And we're going to solve it for Q. We're going to divide both sides of the equation by 9. Let's do that over here in Desmos. First, I'm going to type Q equal to 1107 minus 27P. And Q, then I'm going to replace big Q with what it equals, 9 little q, since there's 9 farmers. I'm going to divide both sides by 9 to solve for little q. Next, I'm going to recognize that 9 divided by 9 is 1, and 1 times little q is little q. I'm going to write this as two different fractions. So I have the original intercept divided by 9, and I have the original slope divided by 9. And then I'm going to move this p to here. And that's the individual demand curve, the disaggregated demand curve that Smith was imagining in his head. Now, this is not the way we would envision it today. This is how he kind of saw it in his own mind without the equations. So the intercept of the individual demand curve that each farmer faced within their stall is 1107 divided by 9. This is the individualized or disaggregated demand curve. Smithian disaggregated demand. The intercept is 123. Now we got to get the slope. To get the slope, we're just going to copy that and paste it here, and we get 3. Now we're going to disaggregate the market supply curve. Again, I'm going to replace capital Q with what it equals, 9 little q, because we have 9 farmers, each supplying this little quantity. And when you add up those 9 quantities, we get the big Q. We get the market Q, the capital Q. Then I'm going to divide both sides by 9, like I did before. If I do it to the left, I got to do it to the right. And then I'm going to rewrite the right-hand side as the sum of 2 fractions. And then I'm going to move the P to the right of this fraction. This is the disaggregated slope, and this is the disaggregated intercept of the individual supply curves of each supplier in each stall. To calculate 387 divided by 9, I'm going to paste it right there, and I get a disaggregated intercept of 43. I'll change this to 18 up here, and I get 2. So I have disaggregated demand and disaggregated supply. This is the Glasgow market demand and supply curve. And each of these, there's 9 of these equations here, and there's 9 of these equations here. Each pair represents the supply and demand in a farmer's stall of the market. And this is kind of how Adam Smith envisioned demand and supply. These equations are disaggregated forms of their overall market equations. The disaggregated supply equation aligns with how modern textbooks present it today. The disaggregated demand equation, however, is a distortion, one that reflects how Smith imagined it while performing thought experiments, walking through markets bustling with buyers crowded around stalls manned by farmers selling the fruits of their labor. I suspect he envisioned the bustling market as 9 scenarios unfolding simultaneously, as if a single stall existed in 9 parallel universes, each with a different price set by the farmer for that day. Each of these universes would yield unique outcomes for quantity brought to market, Smith's term for quantity supplied, effectual demand, Smith's term for quantity demanded, and the transacted quantity. In this light, the price quantity pairs in the tables that follow are points on demand or on supply. Buyers would flock to a stall with a low price, below what we call the equilibrium price, where demand would exceed supply, leading to stockouts. Conversely, a farmer selling at a high price above the equilibrium price would face unsold corn, prompting the farmer to lower prices to clear inventory. As farmers aim to end the day without stockouts or excess inventory, an economic force, Smith's invisible hand, guides prices toward the natural price, now known as the market clearing price. This was a compelling early attempt at modeling perfect competition, as taught in modern microeconomics textbooks. Play and pause the following video to help you solve your version of this problem. Compute all numerical values using unrouted numerical inputs. When entering your answers into the answer boxes, round to 3 decimal places. For any of these multi-part drop-down menu type questions, what I want you to do is I want you to read the scenario carefully. Pick the one that you think best answers the question. If you get it right, great, you'll get a green check mark. If you get it incorrect, what I want you to do then is come to my Zoom office hours so we can discuss it to make sure you get the correct response. Below is the baseline scenario. It represents a typical market day without disruptions, where each stall is operated by a unique farmer, offering corn at various market prices, Smith's term for transaction price. The data below shows the quantity brought to market, quantity supplied, and effectual demand, quantity demanded, at each stall. Complete the table by determining the transacted quantity for each stall. The transacted quantity depends on which one is bigger. If the quantity brought to market, what we call quantity supplied, is smaller than demand, then consumers can't walk away with 87 bags of corn. They can only walk away with 67. This price is low, so bargain-hungry shoppers flock to this stall. They want to buy 87 sacks, but there's only 67. So the transacted quantity here is 67. At this slightly higher price, Farmer Green is asking for 13. And he brought 69 sacks of corn to the market. 84 people are there wanting to buy those 69. So the transacted quantity is 69. Down here at the bottom, Farmer Field is charging a price of 20. Perhaps Farmer Field has higher cost or believes his corn is of higher quality. So he's charging a higher price. Or for whatever reason, he's charging a higher price. He brought 83 bags of corn to market. But at this price, only 63 people are wanting to buy these 83 bags. So 83 are not sold. What is sold is 63. So a transacted quantity is just a minimum of these quantities in each row. So here for Farmer Red, the transacted quantity is 71. For Farmer Ted, it's 73. It's 75 for Farmer Gray. The smaller of these two numbers is 72. For Farmer Hill, the smaller of the two is 69. And for Farmer Wood, it's 66. Now notice as the price rises, what is going on with quantity brought to market or quantity supplied? As the prices go up, the quantity supplied goes up. As the price goes up, the quantity demanded goes down. And you can already see that the market price, what we call the market price today, would be 16 here. The difference between these two numbers would be called today excess demand, because at this price, quantity demanded exceeds quantity supplied. At this price, this difference would be excess supply, because at 20 pounds per sack, 83 are supplied, only 63 are purchased. In lines 1 and 2 of this Desmos.com model, which I've opened up over here, enter the values of the above table into the appropriate tables, and then click the icons with the 4 dots and align through them in the top left corner of rows 1 and 2. Doing this performs a simple regression for both sets of data, with Q1 being the quantity brought to market, quantity supplied, and Q2 being effectual demand, Smith's term for quantity demanded. Complete the following equations using the estimated equations from Desmos.com model. So I'm going to replace the 44 here. Notice that the prices of both these tables are identical to the prices here, but the quantities differ. So I'm going to replace 64 with my 67, 46 with my 69, and etc. I'm going to put the video on pause, and I'll return when I got both quantity columns completed. Welcome back. I've got my quantities for quantity supplied and my quantities for quantity demanded inserted in both these Desmos.com tables. It says to click the icon with the 4 dots and align through them in the top left corners of row 1 and 2. That's this icon here. So I'm going to click that to add a simple regression line. And I'll do the same thing down here. Know that you inserted this information correctly if the R square in both equations is equal to 1. And that is the case. The R equal 1, that's the correlation. And down here, the R equal -1 is the negative correlation. And both these numbers in absolute value are equal to 1. If these both aren't equal to 1, then you made a mistake entering your data. And I'll show you. If you made a mistake here and you entered 6 instead of 63, these numbers would not be equal to 1. So if you have numbers down here that are not equal to 1, double check your data. Make sure these numbers are entered correctly, which means both of these are going to be equal to 1 here and there. For my quantities supplied versus my prices, my supply equation is 2x plus 43. Y is the quantity supplied, and x is the price. Because on any given point, the first number in a point is the x value, and the second point is the height above this x value. So the slope here is 2. That's 2 times x plus 43. This should look familiar. It is this disaggregated supply curve that we already computed. For quantity demanded, it's a function of price. We have to go down here. Again, P is x because the numbers on the left correspond to the values on the x-axis, and the numbers on the right correspond to the heights above these values. So x here is P. So the slope is -3. I'm going to enter 3, not -3, because that is a minus. So I got -3x, or P in this case, plus 123. And that looks familiar because it is our disaggregated demand curve. To find the natural price and the quantity brought to market, Smith's word for quantity supplied, and effectual demand, Smith's word for quantity demanded, at that price, click the point where the two lines in Desmos.com model intersect to answer the following. So I'm going to come over here. I'm going to widen this out. I need to find the intersection here. There's my demand curve and my supply curve. I want to get the point that corresponds to the origin right there. And then I need to stretch the x-axis. So I'm going to click on the wrench. I'm going to change the maximum value of the x-axis to what looks like, well, this is 100. That's 50. I'll change it to 50. There we go. Now we can see the demand and supply curve. I could actually change it to maybe 50 here. There we go. Now the corn farmers will sell what quantity and buyers will purchase what quantity at the natural price. The natural price is the height of this curve here, and the height is 75. In the Smithian model of demand and supply, the x-axis are the prices. So the first number on this blue dot, this intersection point, the first number is the market price, 16. And it was called the natural price in Smith's day. I'm going to enter 16 and press enter. At this price, corn farmers will sell a total of what? At a price of 16, a corn farmer will supply 75. And buyers will purchase 75. And that should look familiar because it's the values that corresponds to this row in the table. At 16, Farmer Gray brings 75 to market and buyers buy 75. So there's no excess demand or excess supply there. The farmer with the largest excess supply is Farmer Field. 83 minus 63 is 20. 81 minus 66 is 15. 79 minus 69 is 10. So Farmer Field is the one with the highest excess supply. Because buyers only buy 63 quarters of corn at Farmer Field's price of 20. And Farmer Field supplied 83 after setting an initial price equal to 20 pounds sterling. I pressed enter to find out if I got those answers correct. The farmer with the largest stock out is Farmer Brown. Farmer Brown set a price of 12. And that resulted in 87 wanting to buy corn from Farmer Brown, but Farmer Brown only brought 67 to market. 87 buyers wanted to buy that corn because his price was low, 12 pounds sterling. Since every man is desirous to dispose of his goods, as Smith puts it, farmers with unsold corn will begin to undercut one another, lowering their asking price so they can leave the market without stock remaining. This underbidding continues until the market price falls back toward Farmer Field has an excess of 20 quarters of corn supplied. Farmer Field wants to get rid of that. So Farmer Field has to lower the price of the corn that is supplied at a stall. And he'll lower that price until it equals 20 pounds sterling. His excess supply is gone at the market price of 16 pounds sterling. This natural price, or what we call the market price, is the level at which the whole produce of the land and labor can be brought to market and sold. For those farmers burdened with excess supply, the cost of bringing corn to market are already sunk. Their aim is simply to dispose of the surplus. There are several farmers who are burdened with excess supply. We have to add those excess supplies up. So let's go down here. We'll compute the excess supply and then we'll sum them up. In Farmer Stone's stall, we have an excess supply of 77 minus 72. In Farmer Hills, we have an excess supply of 79 minus 69. Farmer Wood, we have an excess supply of 81 minus 66. And then, of course, Farmer Field, we have an excess supply of 83 minus 63. Now we need to sum these four numbers up. We get 20 plus 15 plus 10 plus 5. And the total excess supply in this market on this particular day is 50. At the same time, buyers who could not obtain the full amount of corn they desired from farmers who sold out are eager to purchase this very surplus. Their unmet demand, excess demand, likewise totals how much? Excess demand for Farmer Brown was 87 minus 67. Excess demand for Farmer Green was 84 minus 69. Excess demand for Farmer Red stall is 81 minus 71. And the excess demand for Farmer Ted was 78 minus 73. Now we're going to add up these excess demands. 20 plus 15 plus 10 plus 5. And we get 50. Well, these farmers want to get rid of this excess inventory. And these buyers want to buy up that excess supply. And they meet at the price of 16. And at that price, these markets clear. I say markets because you got to remember, in Adam Smith's mind, he's thinking the stall is a market unto itself. I'm just hypothesizing here, and I'm putting myself in Adam Smith's shoes. I'm actually thinking he's thinking that this is what's going on in his universe. And every one of these are parallel universes. So you can think of this as the same farmer, but in different universes. I think that's how Smith was thinking about it. Now, what happens if wages all of a sudden increase? In Adam Smith's time, the supply of farm labor could shrink for various reasons, including rural to urban migration and immigration to colonies in search of better opportunities. With fewer workers remaining in the countryside, farm labor becomes scarcer, raising the wages that farmers must pay. As labor costs increase, farms may struggle to plant or harvest crops on time, maintain fields properly, or complete other essential tasks, ultimately reducing overall agricultural yields. The table below has been transcribed from Smith's Imagine notebook and shows the prices and quantities he observed after higher wages were paid to farm laborers. Use this table to analyze how the corn market in Smith's village was affected. Based on his observations, would he expect to pay higher prices for corn? So we're going to essentially just replace the numbers that have changed in our tables over here. I'm going to delete all these rows here. I'm going to add a second table. I'm going to change the color to black. So the black represents the initial conditions, the baseline scenario. Well, it looks like the quantity demand values are all the same. They haven't changed. The quantity supplied values have changed. They're now smaller. Up here, I'm going to click on the plus in row 3. I'm going to add a table for the new quantity supplied. I've made the quantity supplied values red because these are the result of a wage increase, and red represents the wage increase scenario. So over here, I'm going to enter the same set of prices with different quantities brought to market. I'm going to put the video on pause while I do that. Okay, welcome back. I've entered in the new quantity supplied with the previous price set in this table. I'm going to change this to red. So I got my red dots here. And then I'm going to click on this button here that has these dots with a line through it, and it says add a regression. And notice that my R square is not quite 1. Why is that? Well, let me double check my numbers that I entered. They're all good except for this last one. This should be 68. When I enter the correct number, my R square and correlation are both 1. Now I want to change the line color itself to red. So I have this new supply curve. Can you imagine Adam Smith doing this with Desmos.com? He had to do this in his mind. Used regression to estimate the new supply curve. The original demand curve is still 123 minus 3x, and x is p in our case. So I just need to type a 3 there. The minus is right here. See that? The demand equation hasn't changed. It's still this. The supply equation, though, did change. And the new supply equation is 28 plus 2x. In our case, 28 plus 2p. At a price of 12, the transacted quantity, what we might call the amount that was actually sold, is 52 here. 87 people want to buy a quarter of corn at that price, but Farmer Brown could only supply 52. So transacted quarters is 52. 52 quarters of corn were sold at that price. At this price, Farmer Green only supplies 54. 84 wanted to purchase at that price. So 54 is the quarters of corn that are transacted. And then 56, and then 58, and then 60, 62, 64. At Wood's price, 66 people wanted to buy the 66 quarters of corn Farmer Wood supplied. So on transacted quantity, we could pick either this 66 or that 66. Now at a price of 20, Farmer Field brought 68, but only 63 wanted to purchase at that price. So here the transacted quantity is 63. Now we're going to find the natural price and the quantity brought to market and the effectual demand, which we refer to as quantity supplied and quantity demanded at the equilibrium price. We're going to click the intersection of the two lines. So I have my new supply curve and I have my demand curve, which I held constant. I'm going to click on their intersection. The first number is the equilibrium price, and the second number is the equilibrium quantity. Or in Adam Smith's day, 66 were brought to market and 66 were purchased. So 66 is effectual demand with a natural price of 19. So corn farmers are going to sell or supply 66 quarters of corn, and buyers are going to purchase 66 quarters of corn at the natural price of 19 pounds sterling. Corn farmers will supply 66 quarters of corn, and buyers will purchase 66 quarters of corn at the natural price of 19. Notice that the natural price was 16 initially and then increased to 19. As the price increased from 16 to 19, the transacted quantity declined from 75 to 66. The farmer with the largest excess supply is, again, Farmer Field, because Farmer Field is trying to sell at 20. At 20, Farmer Field brought 68 to market and only 63 were purchased. Buyers only purchased 63 of the 68 quarters of corn supplied after setting the initial price of 20 pounds sterling. The farmer with the largest stock out is Farmer Brown. At a price of 12, Farmer Brown brought to market 52 quarters of corn. 87 people wanted to buy the 52 quarters of corn. Farmer Brown, at a price of 12, supplied 52. 87 people wanted to buy those 52 quarters of corn because the price Farmer Brown had set was just 12 pounds sterling. Now, since every man is desirous to dispose of his goods, again, as Smith puts it, farmers with unsold corn will begin to undercut one another, lowering their asking price so they can leave the market without stock remaining. This underbidding continues until the market price falls back toward what? The natural price in this scenario, which is 19 pounds sterling. The level at which the whole produce of the land and labor can be brought to market and sold. The farmers with excess supply collectively desire to dispose of the surplus, which totals what? There's only one excess supply here, and that's Farmer Field. 68 minus 63 is 5. At the same time, buyers who could not obtain the full amount of corn they desired from farmers who sold out are eager to purchase this very surplus. Their unmet demand, though, totals how many quarters? To find that, we need to calculate the unmet demand. And the unmet demand is the difference of quantity brought to market and effectual demand at each price. So for Farmer Brownstall, it's 87 minus 52. Farmer Greenstall, it's 84 minus 54. For Farmer Red, it's 81 minus 56. For Farmer Ted, it's 78 minus 58. For Farmer Graystall, it's 75 minus 60. For Farmer Stone, it's 72 minus 62. For Farmer Hill, it's 69 minus 64. And we could stop there because at Farmer Wood, brought to market equals effectual demand. Then we just have to add these up. So this pair here is 40, 40, 40. So we have 1, 2, 3 40s and a 20, right? So we can multiply 3 times 40 plus 20, or we could literally add them up, right? 35 plus 30 plus 25 plus 20 plus 15 plus 10 plus 5. Either way, we get 140. So unmet demand here is 140. Unmet demand net of excess supply equals what? We're going to subtract the 140 and the 5 and we get 135, correct? The unmet demand net of total excess supply equals 135 quarters, which will have to be met when? Pick what you believe is the correct answer. If you get it correct, great. If it gets marked incorrect, come to my Zoom office hours and we'll discuss so you can get the correct answer. The same goes for this one. In the next scenario, Parliament caps prices. In his notebook, Adam Smith records prices and quantities after Parliament caps the price of corn at 12 pounds sterling to keep it affordable. This argument, by the way, is used on a variety of products and services today, including public K through 12 education, adoption of children, human organs for transplant patients, certain prescription drugs under Medicare negotiation, Medicaid coverage, generic drugs, rent-controlled housing, utilities, bank reserves via the discount rate, and fuel prices during certain crises. The table below has been transcribed from Smith's Imagine notebook and shows these prices and quantities. Use this table to analyze how the corn market in Smith's Village was affected. Well, notice that the quantity brought to market in every case is 52, and the effectual demand in every case is 87. These two numbers look familiar at that price because this and that are the quantity brought to market and the effectual demand for Farmer Brown in this scenario up here. The transacted quarters in each case is 52. In lines 1 and 2 of the Desmos.com model, enter the values here. I've done that already. Notice that the prices are all 12 and the quantities are all 52 for quantity brought to market. The same thing goes for the other table. The prices are all 12 and effectual demand is 87. And I get equations 4.33p plus 0. And for demand, I get 7.25p plus 0. Now, these equations are incorrect because a government-imposed price cap does not change the fundamental shapes of supply and demand. Government action can't flatten demand, and it can't flatten supply. Demand remains downward sloping since people buy more at lower prices, while supply remains upward sloping since farmers supply less when prices fall. Using modern models and analytical tools, the demand and supply equations for this scenario are as follows. They give the respective quantities in the table above when evaluated at the price of 12 pounds sterling. From the wage increase scenario to the price cap scenario, we're holding everything constant. So the demand equation is still 123 minus 3, and the supply is still 28 plus Q because we're holding everything constant from this scenario to the next. So the equations are identical in both scenarios. I'm going to press enter to make sure I get that correct. And we got that correct, right? Now, it says right here, these equations give the respective quantities in the table above when evaluated at a price of 12 pounds sterling. Let's just check that. So I got 28 plus 2 times a price of 12. That gives me a quantity supplied of 52, these quantities. 123 minus 3 times 12 gives me a quantity demand of 87, which Adam Smith called effectual demand. So that's what is meant by this. Now, in the absence of Parliament's price cap, corn farmers will sell how many quarters of corn, and buyers will purchase how many quarters of corn at the natural price, which we now call the market price. Well, remember, notice that up here, government price is set to 12, demand exceeds supply. So we have excess demand in each one of these stalls. So we can't observe the market price and the equilibrium quantity demanded and the equilibrium quantity supplied. We can't observe that in the table. To find the equilibrium, I'm going to type Q equal to 28 plus 2P. And then I'm going to type Q equal to 123 minus 3P. I'm going to turn off this and that because these are not demand and supply. I got to fit the demand and supply equation in our space here. The quantity axis is fine. Now I got to fix the price axis. I'm going to click on the wrench here and change this to 50 here. Maximum X value to 50. I'll change it to 50 again. Okay, that looks pretty good, right? The origin's right here. Demand and supply meet at 19 and 66. Remember, the first number is along the x-axis, so P is the x. So the first number is the price, and the second number is the quantity. Quantity along the black line is Q2. Quantity along the purple line is Q1. Okay, in the absence of Parliament's price cap, corn farmers are going to sell what? They're going to produce 66. Buyers are going to purchase 66 at the market price, or what Adam Smith called the natural price, of 19 pounds sterling. That's in a free market with the invisible hand pushing prices and quantities to this equilibrium. However, Parliament has cap prices, and you can kind of see that with this dot and that dot. This corresponds to the price cap of 12 and a quantity equal to 52. That's how much farmers supply in their stalls each. This point up here corresponds to the price cap of 12 and a demand of 87. And so the price cap in this model is a vertical line that goes for these 2 points. To do that, remember the price axis is the x-axis. So we're going to type x equal 12, the price cap. And so the difference in the heights is the excess demand that is produced by this price cap. So consumers want to demand 87 in each stall. Each stall only supplies 52. In this situation, the farmer with the largest excess supply, well, that's nobody. Nobody has excess supply here. None of them. Because buyers wanted to purchase 87 quarters from each stall, and each stall only supplies 52 quarters of corn. At the moment, the price was capped at 12. The farmer with the largest stock out, well, everybody's stocked out, right? They're only supplying 52 in each stall, and each stall, 87 people want to buy the 52. So there's a stock out in each stall. So this is all of them. Since only 52 quarters of corn were supplied in each stall, and buyers wanted to purchase 87 in each stall, at the moment the price was capped at 12 pounds sterling. Since every man is desirous to dispose of his goods, farmers with unsold corn will begin to undercut one another, lowering their asking price so they can leave the market without stock remaining. This is not the case here. Instead, farmers have stocked out. Buyers in this case bid up the price until the market price rises to the equilibrium of 19 pounds sterling, which cannot happen because Parliament has capped the price at 12 pounds sterling. The farmers with excess supply desire to dispose of this surplus. Well, again, they don't have a surplus. Since none of them have a surplus, the total of their surplus is 0 quarters of corn. At the same time, buyers who could not obtain the full amount of corn they desired from farmers who sold out are eager to purchase this very surplus. Their unmet demand, though, totals what? Well, unmet demand in every stall is 87 minus 52. So in each stall, there's 87 minus 52 quarters of corn that are unmet. And there are 9 stalls. So we got to multiply that by 9. 315 quarters of corn is unmet. Unmet demand net of total excess supply equals 315, which will have to be met when? I have to go through this answer with you. They won't be able to meet the demand today, so consumers will come back tomorrow looking to buy corn. And remember, there's unmet demand. The buyers are bidding up the price. It'll be the next day at probably even higher prices. If nothing changes, ceteris paribus, farmers will supply what the next day? Well, the farmers today, with the price cap of 12, they brought to market 52 each. And there's 9 farmers, so 52 times 9 is 468. They supplied 468 the first day of the price cap. If nothing changes, tomorrow they'll supply 468. Which means what? Well, today, when the price was capped at 12, there was an unmet demand of 315 quarters. Tomorrow, if nothing changes, the quantity that is supplied in total that is brought to market is 468. It was 468 the previous day, it's 468 the next day. Unmet demand was 315 the previous day, it'll be 315 the next day. So it'll be 315 times 2. So 315 for today and 315 for tomorrow. So now unmet demand is 630 total. And this continues as long as everything remains the same and the price cap remains in effect. Unmet demand builds upon unmet demand, and it quickly leads to starvation and poor health. If people aren't able to eat, a person can survive 3 days without water. A person can survive a couple weeks without food. As the number of days they go hungry increases, the quality of their health decreases, and they become more susceptible to disease. For the rest of these questions, I'm going to leave them up to you. Pick the answer that you think best describes or answers the question, If you get them marked correct, great. If you get some marked wrong, or if you get all of them marked wrong, please come to my office hours. We'll discuss so that you get 100%.